Welcome to section 5.2. In section 5.2, we're going to talk about direct variation. First of all, let's review some things we know about slope. So, for the first one, I want you to cross out the expression below that does not show a formula for slope. Then I want you to underline the correct word in each sentence about slope, the slope of a horizontal line and the slope of a vertical line. Is it undefined or zero? So the first one, which expression does not show a formula for slope, is the first one. Horizontal change over vertical change is not slope. Slope is vertical over horizontal. And the slope of a horizontal line is zero. The slope of a vertical line is undefined. So our vocabulary word for today is direct. Again, direct means straightforward, but for math, we're going to be looking at the ratio of two variables being constant. Then the variables form a direct variation. So in other words, one variable directly affects another by multiplying it by a constant value. Now, the formula that we're going to be looking at is this one right up here. This is our formula for direct variation. Y equals kx, where k is a number all except for 0. That would be a direct variation. And in that, k is called the constant of variation. So let's look at this. A function in the form of y equals kx, as long as k is not 0, represents a direct variation. The constant of variation k is always in front of x. So, to figure out if an equation represents a direct variation, we've got to solve the equation for y. If we can write the form or the equation in the form y equals kx, as long as k does not equal 0, then it's going to be a direct variation. So let's take a look at an example. Does 4x plus 5y equals 0 represent a direct variation? If so, we're going to find the constant of variation. So first of all, which is our equation that shows direct variation? It's the one in the middle, y equals kx. So first thing we're going to do is we're going to try and solve this equation for y. So we have 4x plus 5y equals 0. We're going to subtract 4x from both sides. Then we're going to divide both sides by 5 to get y equals negative 4/5 x. Does this represent a direct variation? Yes, because it can be represented in the form y equals kx, where k in this case is negative 4/5. So here's another example. We have 12x equals negative 36y. Well, if I'm solving for y, even though it's on the other side, notice we're going to divide both sides by negative 36, so y equals 1/3 x. That is a direct variation, and the constant of variation is 1/3. In this example, we have negative 7 plus 9y plus 7 equals 2x. So again, we've got to solve the equation for y. So we've got negative 7 and a positive 7 canceling out, leaving me with 9y equals 2x. Divide both sides by 9 to get y by itself. Y equals 2/9 x. This is a direct variation, and the constant of variation is 2/9. Let's take a look at this one. 3x plus 4y equals negative 5. We've got to solve this equation for y, so we're going to subtract 3x from both sides. We're going to divide everything by 4, and we end up with y equals negative 3/4 x minus 5/4. This is not a direct variation because it's not just y equals kx. I've got this minus 5/4 tagging along, so it's not going to be a direct variation. And therefore, we don't have a constant of variation. Another problem that you'll do in your assignment today is one that looks like this. If it tells you that y varies directly with x, and it tells you what y and x are equal to, y is equal to 10 and x is equal to a negative 2, we got to figure out the direct variation equation that relates x and y. And then we're going to figure out the value of y when x equals 15. So these are the steps that we're going to take. First of all, we're going to start with the formula, y equals kx. We're going to substitute the 10 in for y and the negative 2 in for x, and then we're going to solve for k. Dividing both sides by negative 2, k equals a negative 5. Then we put that back into our formula, y equals negative 5x, and put the 15 in, the negative 15 is actually what they wanted us to do. The negative 15 in for x, and we end up getting negative 5 times negative 15, which is positive 75. So let's try another one of those. We are going to suppose that y varies directly with x. We're going to write a direct variation equation that equates x and y. Then we're going to find the value of y when x equals 8. So we're substituting into our formula y equals kx. We're going to divide both sides by 5 to get k equals 2/5. And then we're going to figure out what the value or the y value when x equals 8. So using our 2/5 for k, our 8 for x, we multiply and get y equals 16/5. Here, y equals 6 and x equals 18, so we're using our y equals kx formula. Substitute in the 6 for y, the 18 for x, divide both sides by 18, you get k equals 1/3. To figure out what y is equal to when x equals 8, we're going to multiply both, or we're going to substitute in the 1/3 for k and the 8 for x and get y equals 8/3. In this last example, y equals 10 when x equals 2. We're going to substitute into our formula 10 equals k times 2. Divide both sides by 2 to get k equals 5. And then what's y going to equal when x equals 8? Well, we're going to substitute in 5 for k, 8 for x, y equals 40. Take a look at your homework assignment. It's on page 302, numbers 9 to 20.